just tuning some stuff up. There's a bunch of stuff I've wanted to talk about for a while with respect to the computer industry and what's been going on. The primary problem is that we let people touch computers and they don't know what they're doing. And now Twitter's made a bunch of updates. And just first of all, like, you don't need to be a genius or a computer programmer to figure out when something's wrong with software. If you're updating your software more than like once a month, terrible. Like, I don't know what you're doing. You should stop. You do something you're good at. You're not good at that. You're just not good at it. Nobody wants their software changed that often. Nobody. It's unstable. It's technically unstable, right? So either you're releasing too many bugs, and which is why are you ever releasing? I've worked at companies that had no bugs. It's not actually that hard to do, and I'm going to talk about that later, like how to do that, because this is not hard. It's a solved problem. Solved in the 90s. This is a very long solved problem. Or you're just changing features all the time and screwing people's lives up. Like, either way, no one wants either of those two conditions. Don't release software like updates 3 times a month, 4 times a month, once every couple of days. Like this thing, I'm gonna smash it. I like, you got to be kidding me. There's 12 updates every 3 days on 100 apps. What are we doing? What are we doing? Twitter is out of control. I don't know what they did. Everyone's like, oh, my feed is so much cleaner. Well, except the feed doesn't actually work correctly. So maybe it's better. I can't really tell. I'm always struggling with it to get it to update correctly. And then when it updates, it puts the stuff in at the top. And then I have to scroll down to get to the bottom. But now I'm at the bottom and the updates go at the top again. Are you people all stupid? Like, you can't have that many stupid people in your company at once, can you? And I guess they can, because what other explanation? And that there was a bug previously with Twitter where it would do the show more posts thing. And then what you had to do on Android was you had to put show more posts at the very top of the screen. So the pixels were a little overlapping, a little off the screen. And then you had to hit show more posts. And if you did it that way, it wouldn't do that weird scroll thing where it scrolls to the top instead of like pushing up, which is what it should. Like, where do these people, what are they doing? I don't understand. So now we're back to, instead of infinite scroll, right, we're back to buffering again, which is fine. Buffering is the correct answer. Infinite scroll is always a stupid idea because people just don't understand. Software engineers are very bad at understanding volume. Very bad. Like, they don't, because they think in discrete tiny parts. So they think like, how do I break this into discrete tiny parts and then build a procedure? Blah. Fine, fair enough. But they're very bad at understanding A. But when you have a million, you have to have a mechanism to deal with that. Like, you can't treat a 10-item list like a million-item list, because you need different data structures, among other things. Like, there's all kinds of problems that can be, like, I can't absorb a million lines, right? Like, I can absorb 10, right? You can't say, oh, you make it 10 at a time and break it down from a million? No, you don't. No, you absolutely, no, it's not how it works at all. Scale changes everything. And I've been doing a fair bit of AI coding, which, has gotten a lot better. I don't know what they're doing, but finally they got the average to low tier programming data out of the training set, clearly, which is good. They never should have put it in there in the first place. They should just train on much smaller code bases that were actually written by people who know what they were doing, but no one ever thinks of this. So this whole more is better thing. So I noticed that, it's relatively easy to get decent code out of the coding things. It's really, not super hard. Oh boy, where did I leave off? So, stupid phone calls. But that's what you get in the 2-bit channel. If you want better presentations, you get to go to navigating patterns. That's all the good stuff is. This, when you're coding with the coding AIs, what they've figured out, because they're just, learning new things every day that we were doing in the 80s, is that you can have it run its own tests. Now, the thing is, and I know this because I was a consultant in the computer industry for 30 plus years, they stopped testing. I mean, it should be clear, right? Like, You can't tell me you've got all these upgrades and you were testing correctly. It's not possible. Like one or the other is true. You can't have both. And you say, well, we run tests, but they're not good tests if bad software is getting out into the world, right? Obviously, your tests are terrible. They're not terrible, right? And there's no way around that conclusion. Believe me, I had to argue with people all the time about this. And usually my clients, they'd be like, well, your testing's not working because, oh, no, we're definitely testing. I'm like, well, do you want me to fix your problems in production or not? Because fixing the problems in production means fixing your tests, always. So in order to get these coding AIs to do better, no matter where you look, you're going to see it. Oh, you want to put it in a loop. And part of that loop should be a test. And it's like, yes, it should be a test. That is correct. Right. And so it's doing your QA. In the old days, everything always got QA'd. Always. Like everything. Always. They had a QA department. QA department held up releases as necessary because if the software had bugs, it wouldn't go out the door. We've done away with all that. They flattened the software industry completely. So there's no more testing. And the people that are testing are software engineers. Well, let me tell you what software engineers can't do well at all, and that's test. They can't test their own code well, and they can't test code in a way that reveals bugs in production well at all because they don't understand the system. Right? They typically don't understand how their code works, and more importantly, they never understand how their users use their code. They understand how they think their users use their code and how they want the code to be used, but they never understand how the users use the code. Obviously, I mean, again, Twitter, like they clearly didn't run this on an Android and say this is okay. No one did that. No one did that. And I could argue, look, their web interface is horrible for other reasons, but like they didn't do that. No one thought this is a good idea, right? They simply don't know. And the only way you don't know that your software is doing something stupid is if you're not testing it correctly. Period. End of statement. And so the coding engineers, or coding tools rather, can be better than engineers because they'll run in a test loop. In other words, what I'm telling you is every piece of software that you use or see today could be instantly improved by adding a QA department before release. Now, I understand nobody has release anymore. We've moved to a deployment-only model. Deployments in my world, in the original DevOps world, before it was even called DevOps, I was doing this. I had this whole system down. Were meaningless. They were just meaning. Oh, you're moving some blob from somewhere to somewhere else. Lovely. I don't care, right? Because I only cared about release, and release is moving things through a process, right? Starting with, from my perspective, not what the developers are doing. I never cared. The developers can shoot themselves in the foot all they want, right? Because if you use a process like the following, it doesn't have to be exactly the following, but if you want me to give you a custom process, go pay me a few $1,000s and we'll chat, right? Because this is what I used to do for a living. One of the many things. First, it goes into some kind of testing phase, usually automated, and then it goes through a Q&A phase, usually automated. I would usually add in an additional testing phase called an integration test, right? And then it would go through yet another phase into what's called the staging environment, right? And then it would go into production. And so that process of moving through those stages, that's the release process. Now, the release only happens when a successful deployment makes it all the way through the process. In other words, it passes either all or enough of, with exceptions, because sometimes there are exceptions, the tests. And nowadays, you would add an additional stage, which we never had because you never needed it, which would be the security testing, right? Like nobody ever needed security testing. That should tell you something about how much software engineering has changed. You need security testing in the old days because security is A, really easy to do if you do it at the systems level and don't try to do it in code. And B, it was built into the architecture. But because you're doing fast builds and deployments and, what's it called? Quick release and fail fast and all this other garbage. It's all garbage, by the way. It's all garbage. I'm not saying those principles aren't useful. I'm saying fail fast is a stupid idea. Like, plan it out and then you don't have to fail at all. That's a way better. It takes longer. That is true. But it gives you a better quality product on average period. And it's a much better quality, much longer lasting. It releases all the time, right? Because you don't have to fail at all. You can avoid the fail fast, or at least elements of it, right? Fail fast in development. You fail slow in QA. You fail not at all in staging, right? And security. So staging is where you put your security testing as well, right? And then production. So one release was one deployment to production. Now, how many actual deployments that is, it could be just one stage for pipeline because your damn engineers got it right for once on the first try, which is very, very rare, but it does happen. Good teams, right? But it's usually 3 to 6 tries, right, through the system and getting bumped back from usually from QA, sometimes from integration testing, occasionally from staging. Oh, your performance is in the tank. We caught it in the staging environment, right? Or, oh, there's a weird data error. And usually with the staging environment, you have, we'll say, a sufficient enough copy of your production environment or sufficient access to the production environment that you can find data errors, right? Because data errors are always sneaky, right? Because you only really have 3 types of bugs, right? You have like actual coding errors, right? Those are common type. You have uh, integration errors where the code works just fine, but it's not interfacing with either the system setup or the other pieces of code as written, right? So those are much harder to find bugs. And then you have data errors where what happens is the code works completely fine, but it doesn't account for some condition in the data because the software engineer didn't know the data got in that state. Maybe it's a state they should have known about. Maybe it's a state that happened as a result of a corruption. Maybe it's just an older format of the same data and it just never got upgraded. Who knows, right? So there's only really those 3 types of bugs. And then in staging, you could find all 3 sometimes, most of the time, right? And then occasionally something would slip by in production, but very occasionally. And I worked for a Fortune 500 company that had 0 bugs. They released 0 bugs. Every time they released 0 bugs. They also wrote the software that makes all of the chips, like actually, right? All the Verilog and all that nonsense. That's what it did. So it had to be bug free because once you like design a chip and send it to the fab, it's all over. Like it's all over. Has to be. Now, it can be mathematically perfect. So lower bar for them in some sense, although that software was huge. It's just absolutely huge amount of software to do that back in the late 90s, early 2000s. But it is possible. It has been done. I've seen it. I've seen it done at scale. I've seen it done in smaller companies. It's perfectly possible. I have written not, we'll say commercial software, but I've written tools that bug free, that not a problem, that have run for years and years. It's not really that hard. It takes a lot of planning. You can't do it fast. You can't fail fast. You can't do that. That's nonsense. But and the thing about things like fail fast is like, no. When you have an error, find it quickly and rectify it immediately. Oh, sure. But that's kind of obvious advice. Why would we need to use a new term like fail fast to kind of figure that? I don't know what you had to lose first, but you lost a lot of stuff to get there. So all of this is to say that if you want to be a better developer, have a testing cycle that doesn't involve just you, and you will improve in your development. That is so effective, it can be used with AI. That's the way to look at it. And it sounds a little backwards. AI is not smarter than you. AI is not better than your average developer. It really isn't. It's a little bit below, actually. But if you put it in a process, in a very strict process that it doesn't own entirely, right? Because usually the AI will spawn an agent for the testing, right? It will improve itself. And you can improve yourself if you have other people QA your software. And look, QA is tricky. Finding good QA engineers was always hard, but they exist. And if you find one, just pay them a lot of money and keep them happy. Without that, without a physical person doing your QA, keeping track of your regression errors, because man, regressions, that whole concept is gone. Like regression testing was a whole type of testing that no one ever does anymore, as near as I can tell, because I see nothing but regression bugs left, right, and center in the software. And pretty much every piece of software, I'm like, what are you guys doing? You've had this bug before. You can't even run a test to make sure it didn't reintroduce itself. Like, how dumb are you? Like, you can be the best software engineer in the world, but it ain't gonna help you if you can't do regression testing, man. And that's an automatable process usually. So I don't know what's going on. But just his hilarity of rediscovering the old principles of software engineering because we now have these junior level coding engineers called coding agents. It's just, I mean, you do you, whatever. I guess it's kind of silly. I kind of think it's funny. Um, I wish we weren't living through this ridiculous timeline. And man, everything I thought when I was young about software and the trajectory of technology is completely wrong. Completely wrong. And why? Because once you flood an industry with people, like we've done in the software industry, it's all over. It's all over. That industry is going to go to shit no matter what you do. And that sucks. I don't like it. I like the old days when I could command a lot of money and I had 10 job offers a week every week. And I was, turning down opportunities to fly around the world, which in hindsight I shouldn't have done. I should have made tens of millions of dollars instead of settling for, a few million, throughout my career. But, it is what it is, I guess. Live and learn.